Hello guys, this is a bonus video. It's video 4.5. It's technically not assigned. However, if you have any difficulties with the material that we go over in class, then this is a highly suggested video. Remember, the stoichiometry is pretty much the conversion of one substance to another and calculating those values. So in the previous video, we spoke about corn muffins and calculating how many corn muffins we can make from so many eggs and so many boxes of corn muffin mix and milk and whatnot. So today we're going to do a problem. I have written down the problem for you. Once you see the problem, take some time to write it down. How many moles of carbon dioxide are produced when 10.5 moles of propane, and I give you the equation there, C8H8, are burned in excess oxygen? You also are given this equation. Pause now and take some time to copy down the equation. So first thing you may have noticed is that I took two different colors and I underlined my known and my unknown. My unknown is in blue, my known is in brown. If you don't have two colors, what you can do is you can box the question, box the known or underline the unknown or shade it in, just so that you can distinguish the two. So take some time now, pause, and see if you can come up with the known and the unknown written down in the normal format. Now, when I did this, I came up with my known and my unknown. My known was the 10.5 moles of propane, and my unknown was the number of moles of carbon dioxide. Notice that I've also written my known and unknown a little differently here. You have an actual chemical equation. I've written my known above the equation over the specific chemical that I'm looking for, and my unknown below the equation. This saves you a little bit of space and time. It doesn't matter to me which one you do. You can either write the equation and the known and unknown separately, or you can use the equation as the basis of communication. It's up to you. So let's get into solving the problem. Now, if we look at our known is the moles of known. It's the unit moles of known from your stoichiometry math that you received in class. I'll try to also link one to the bottom of this page so that you have it available. Then here we have the moles of unknown. So we're looking for moles to moles. Now, if we were to look at our stoichiometry math, we could see that our conversion factor is going to be path E, from moles of known to moles of unknown, and that is the mole ratio from the balanced equation. There were two possible mole ratios that we can get from the balanced equation. Based on what we learned in the last video, video 4, pause right now and see if you can figure out what the two possible mole ratios are between the moles of known and the moles of unknown using the balanced equation. You should have come up with two alternatives. One is 1 mole of propane for 3 moles of carbon dioxide. The other option is 3 moles of carbon dioxide for 1 mole of propane. The question is, which one are you going to use? So to think about that, you have to think about your setup. Our setup typically has our brackets with our known in the first column and our conversion factor in our second column. If our known is our 10.5 moles of C3H8, that'll go here. We're going to need our conversion factor to have moles of C3H8 here in order to cancel. So in that case, this option here is the best one. This one will not work, and in fact, it will give us the wrong answer. So if we put in our known, which is the 10.5 moles of C3H8 here, and we put in this conversion factor, E, here, our result looks like this. These units will cancel, and in your calculator you're putting 10.5 times 3 divided by 1. You're going to multiply across the top, 10.5 times 3. If there's more than one thing on the bottom, you'd multiply across the bottom, and then you would divide the top by the bottom. That's the process for solving these. Some of you have asked that question. Once you put all that in, you'll get in your calculator 31.5 moles of CO2. And then we have to remember that we need to put that in scientific notation and significant figures. Based on the 10.5, we would need 3 significant figures. So our final answer is 3.15 times 10 to the first moles of carbon dioxide. Continue to try mole-to-mole problems. Anytime you see a known of moles and an unknown of moles, you know you're on the right track. And keep practicing. This particular topic is all about practicing. Make sure you have your mole map and your periodic table and a calculator. And as long as you practice, you'll eventually get it. Be sure to ask any questions that you have in regards to this problem in class. You can email me, or you can also insert a question at the bottom of the page where you see this link. Thanks so much. Bye-bye.